Um, uh, when we talked about this last time, we graphed something with a plus or minus in there. To get that into my calculator, I need to use two lines in my calculator. So I'm going to do one line for the plus and then one line for the minus. And if I go ahead and graph that guy, I would say not a function because it fails a vertical line test. So sketch a little picture of the graph and say that would constitute work and an explanation. Does that feel okay?
Yeah.
Okay. Miriam.
So for number two, you would have to put it like there's like two Y lines. So when I did that, like it was kind of like the same thing. Sort of.
Mm-hmm.
So would that not be a function because they both intersect, or is it just one button?
So you would take this as both graphs at the same time as the function. So the picture you're looking at is your function. So this fails a vertical line test, right?
Yeah.
Not one at a time. It's both at the same time. Not a function. Correct. Yep. You're right on. Who's else? Do we have any more?
Wait, so for number one, like
Yeah.
even though it's a square root, would it not have plus or minus?
If it wasn't written there, we don't insert a plus or minus. We get the plus or minus when we do it to both sides of an equation. So if it's already there, it is what the symbol in front of it says. It's if we're the one that writes it in by doing it to both sides of the equation, that's when the plus or minus comes in. Right? Like if I ask you what's the square root of 4, well, that's just 2. Not plus or minus 2, just 2. But if I ask you what squared is equal to 4, that could be 2 or negative 2, right? That's kind of the difference. One of them, the square root symbol's there, it just is what it is. The other one, we're putting the square root symbol in. That's why we're getting the plus or minus. Is that?
Yeah.
Okay. And it's a good clarification question, right? Like, it's got a square root in it. Do I need to put that in there? It's, like it's a subtle difference. So it's a good thing to ask about for sure. Anybody else? Last chance. Going once, going twice. Okay. If you change your mind and you get a little bit further in the homework and you don't have any questions right now because, I haven't gotten that far into my homework yet. I just did the first, a couple of the first ones. That's okay. You can always ask again on Friday. It's not like today's the only day to ask about 1 through 12. If you get a little bit further and you're like, 8, what the heck? You can always ask again on Friday or come find me during community time or something. Like, that's fine too. Everybody good? Okay. Let's pick up where we left off. So I think we're going to be starting to talk about 1.3, talking about continuity. So in this last, we started off talking about functions, right? That was like the first section was all functions. What's a function? What's not a function? How do you tell functions? These next couple of sections are now going to be talking about like adjectives we can use to describe attributes of our function. So like domain and range tell us about a function. Continuity is going to be describing like an aspect of the function. So the next couple of sections, we're just going to be like coming up with adjectives to how do we talk about these functions? Like how do we say, it does this thing or that thing or whatever. Okay? So when we talk about continuity, we say a function is continuous if we can draw the graph of that function without picking up our pencil. So like, boop, continuous, right? If I can just draw it the whole way, if I have to pick up my pencil to draw it, like I have to do one of these and then pick up my pencil and do one of those, not continuous anymore. At least not everywhere continuous, right? Still continuous for part of it, but there's a point where it's no longer continuous and then a part where it continues again. We call any break in continuity a discontinuity. And there are 3 types of discontinuity. So we have a infinite discontinuity. In your Algebra 2 class, depending on how far you got, you potentially talked about these. We also refer to them as vertical asymptotes. You could use those two terms interchangeably. So an infinite discontinuity is the same as a vertical asymptote. For our purposes anyways, they mean the same thing. And let's draw a picture, I guess. So if you remember from Algebra 2, if you got that far, typically we draw a vertical asymptote or indicate a vertical asymptote on our graph by drawing like a dashed line. And then we would draw like something like that, right? So our infinite discontinuity is that vertical asymptote. Notice to draw this graph, I can draw like the one part, but then I have to pick up my pencil to draw the next part, right? There's a discontinuity there. There's a point where I have to pick up my pencil to keep on drawing. Also worth pointing out in the situation where we have an infinite discontinuity is you're going to have 4 arrows on your graph. Those arrows are called end behaviors. That's the name you give for the arrow at the end of the graph. It's called an end behavior. So every time you have an infinite discontinuity, you have more than the usual 2 end behaviors. You have twice as many as you would expect, right? If you have 1 infinite discontinuity, you'll have, 4 end behaviors. If you'll have, 2 infinite discontinuities, you're going to have 6. If you have, et cetera, et cetera. Did you guys talk about vertical asymptotes last year? Remember that? Some of us did, some of us might have. Because we had 2 different sets of teachers, right? Half of us had one teacher, half of us had another. Is that what? Yeah, okay. So getting to a little bit different points is understandable. The next type is called a removable discontinuity. So what this looks like is just a regular old curve, but you have one point that's missing, right? I have like a little hole in the graph. Usually we represent that when we're drawing it by hand with like an open circle. You know how like when you draw stuff on the number line, you put an open circle for not included? It's the same notation here. We're just putting an open circle where there's like, oops, there's a point missing. So that's just like a little gap. Everybody's okay? Did we see that notation or that situation last year in your Algebra 2 class? Probably not. That's okay. It's been a minute since I've taught the honors versus regular. I couldn't remember if you do it in both classes or just one. Might be an honors only one. Not a big deal. And the last type is a jump discontinuity. So an example of what that might look like. Maybe it's something like this. Again, I can draw one part of it, but then I have to pick up my pencil to draw the other part. But it's just basically like we, like snapped the graph at a spot, and we picked up half of it and just moved it up or down or something. Right? We just like cut it and then moved it. That's kind of what the jump discontinuity looks like. So note here, I have the ends of my jump discontinuity. One is open and one is closed. Does it matter which one would be open and which one would be closed? No, it would still be a jump discontinuity. Could they both be open? Sure, that's okay. Could they both be closed? Could both of those circles be closed? No, good. Why not? What? The line would connect. Well, it doesn't have to. Like if I filled in that circle there and the line doesn't connect, that's still bad. But why would that be bad? So we covered it last time. What would happen if I filled in that circle? It would fail a vertical line test, right? No longer would I have a function. So you'll never see a jump discontinuity where both ends of your jump are filled. You'll either have one will be open, one will be filled, or both could be open, but you'll never have both filled because it's no longer a function. Is everybody okay with that? I like talking about that because it brings it back to last time. That's always nice, right? Okay. So let's do a quickie little example here. So let's look at a couple of examples. So here we're just going to take a look at these and decide, do they have a discontinuity? And then like, what kind of discontinuity is it? And then where's that discontinuity at? So what do you think I'm going to do first? What am I going to do first? Go ahead, Jake. No. Jacob. Yeah, I'm going to graph it in the calculator. I want a picture. When I gave you guys the definition of these discontinuities, I was looking at a picture, right? If I have a picture, that's going to make my life easier. Yeah, first thing I want to do, get me a picture, right? We didn't give you any other kind of definition for a discontinuity other than the picture. You know, like that's what I want. So to type this into my calculator, I want to get that horizontal bar so I can type this in exactly like it looks like on my sheet of paper. The easiest way to get that is to press the green alpha button and then the y equals, and then pick the first option. That'll give me that horizontal fraction bar so I can just now type in this equation exactly like it looks like on my sheet of paper. Everybody cool there? If it's been a while since you've graphed anything, I recommend pressing Zoom Standard instead of just Graph so that we reset our window back to something sensible. I've been using my calculator all day today, and who knows what kind of kooky windows I've cooked up wanting to use at some point or another. So I'm going to go ahead and start every class by doing Zoom Standard instead of just hitting Graph because I can't remember what I did 10 minutes ago, let alone earlier today on the calculator. All right, so if I look at this, do I see any discontinuity? Yeah, definitely, right? Like I can't draw that graph with one connected, like one single pencil stroke. That ain't gonna happen. How many places would I have to lift my pencil? Looks like twice, right? I can draw this part with one pencil, then I have to pick it up. I draw this part with another pencil stroke, and I have to pick up, and I can draw this part. So there are 2 times I had to lift my pencil, right? Even though there's 3 parts of my graph, I only lifted my pencil twice. Everybody's cool? So there's 2 discontinuities. What do they look like from the picture? Are they infinite, removable, or jumps? Infinite. Good. So I have 2 infinite discontinuities. Notice that I didn't do any math here. I've just graphed this thing on my calculator and looked with my eyes. I haven't done any like sneaky calculation or anything like that. I've just known what the picture I was looking at was supposed to look like, and it's like, oh, that's what I saw. right? Now there's one other part that I wanted to do. I also wanted to tell the location of these discontinuities. So if I look at my calculator, it looks like right about here is where that vertical line is. Everybody kind of see that? If I count to where that is on the x-axis, I went 1, 2 units to the left, and then that's where the vertical line is, right? Everybody okay with that? So I'd say, okay, well, one of those discontinuities is at -2. X equals -2, actually, I should say. And the other one looks like it's like right about here. And if I count, that looks like 1, 2 on the x-axis. So the locations look like they're at -2 and +2. What do you notice happens if I try plugging -2 or +2 into my function? What do you notice happening if I try plugging -2 or +2 in for the x in f of x? Yeah, I have a denominator of 0. Excellent, right? 2 squared minus 4 is 4 minus 4. That's 0. So it seems like anytime I have a 0 denominator, maybe I'm going to have a discontinuity. You guys see that? Okay. Let's see if that happens every time. Let's try the next one. That's a good observation, right? +3. So again, I use that alpha y equals and put option 1 to get that horizontal fraction bar, which is a really nice shortcut to use. It really makes life enormously easier if you're able to type stuff in exactly like it looks like on your sheet of paper. You don't have to muck around with a bunch of parentheses if you don't need them. Okay, let's hit graph and see what we get. Do you see any discontinuity here? Doesn't seem like it, right? Well, before we go ahead and say there isn't any discontinuity, look at my function. Is there a value of x that would give me a 0 denominator? -3, right? -3 plus 3 would be 0. Let's go and take a closer look at what's happening at -3. Looks like on our function that looks like the point maybe -3, -5 if I'm kind of counting. So I'm going to zoom in close to there. So let's pick maybe a little bit less than -3 and a little bit more than -3 and maybe a little bit less than -5 and a little bit more than -5 and hit graph now. Ah! What do you see there? It's hard if you're in the back. What do you see?
What did you type in after you hit enter?
It's right here. That's supposed to scare you. Just want to make sure everybody's awake. It's dark and stormy and 8th hour. And this is prime sleeping weather right now here, folks. I get it. I'm ready for a nap too. Luckily, I get to drive an hour home through the rain, so that'll be fun. It'll probably be more like an hour and a half today, which is even nicer. Okay, let's go back and look at that picture again. What do we see right here? What do you see? A little tiny gap. What does that mean? That's a removable discontinuity, yeah. And surprisingly, or maybe not surprisingly, that happened exactly at -3. Why -3? It's where the denominator became 0. So there's two options, right? If you have a 0 denominator, you might get an infinite discontinuity, you might get a removable discontinuity, but you're going to get some kind of discontinuity, provided the denominator can become 0. I don't have a good example of a jump discontinuity. We need to use a piecewise function to do that, and we're not going to do that right now in this class. Miriam.
So like the denominator, did you just not up like try to
I mean, I just looked at it, right? What value of x would make x plus 3 0? -3. So I said, okay, well, there is a number that makes this denominator 0. Let me look at what's happening there to see if there is a discontinuity there, because that's what happened last time. So that's why I zoomed in there to see maybe there's still a discontinuity. We had to happen last time there. It doesn't look like there's anything there, but maybe it's being sneaky. And it was hiding, right? It was right there, a little tiny gap. It's hard to see from all the way in the back, and you're wearing glasses, which I don't ever, oh, so they're not even corrective. There, maybe you have excellent vision then. Who knows? Back when I was a youngster, I had like 25 vision, really, you could read the bottom line of the eye chart. It's not that good anymore, but still good. So I never think about the people that can't see, because it was I've always been able to see really well. Not bragging, just telling you stories. Anyways, questions about what we've done so far? Not too bad, right? Pretty much a nothing burger. It's just okay, that's what the thing looks like. I just have to graph it and look for it, and then say where it is. That's it. That's all we're saying. Okay? That's continuity. That's all we need to care about continuity, at least right now for this class. Our next section, we're going to talk about increasing and decreasing functions and extrema. Oops. So let's start with defining what we mean by increasing and decreasing. So we say that a function f is increasing on a given interval if for any 2 points on the interval, a positive change in x results in a positive change for f of x. For decreasing, it's just going to be a negative change for f of x. And for constant, it's no change for f of x. But we read this and you say, Mr. Kulik, what in the world does that mean? So this is the way you'd want to think about it. You want to imagine you have a little tiny man, and that little tiny man is walking along the curve of your graph, moving from left to right. The part of the graph that he's walking on that goes uphill is increasing. The part of the graph where he's walking that goes downhill is decreasing. And the part of the graph that he walks on that's flat is constant. That's the idea. So you imagine there's a little person that's walking along your graph, walking from left to right, just like we read, has to be from left to right. When he walks uphill, that's the part of the graph that's increasing. When he walks downhill, that's the part of the graph that's decreasing. And when the graph is flat, that's where it's constant. That's what those definitions are saying. That's the easier way to think about it. Let's do some examples. Sound good? I think so, Mr. Kulik. but let's see it done before I commit to that. Okay. So let's look at this first picture. So again, we're starting, our little person is going to walk along the graph from the left to the right. So here's my little guy walking along the graph. So it looks like if he walks along that part of the graph, we're going uphill that whole time. Everybody kind of agree with that? So that part of the graph covers that section of the x-axis. Everybody agree? I'm going to take that part of the x-axis, and that's going to translate to my interval where the graph is increasing. So if I look at that section of the x-axis, it starts on the left with the left arrow, so negative infinity, and it ends at the x value of -4. And this interval is always going to get parentheses. Intervals of increasing, decreasing, and constant always get parentheses. All of them, every time, every end. It's easy like that. Yay! All right. So now the little man is walking on this section of the graph. So that looks like it's flat. That must mean it's our constant section. That interval starts at, and that corresponds to this part of the x-axis. That interval starts at -4, and it finishes at +3. And again, all of these intervals, increasing, decreasing, constant, always have end in parentheses. So far, so good? All right? Clear what we're doing? Okay. All right. Little man, you're now on this section of the graph. Looks like we're going downhill now. That section of the graph corresponds to that part of the x-axis. That begins at +3, and it goes all the way to +infinity. And again, all parentheses whenever we're doing increasing, decreasing, constant. No brackets. All right. No big deal. So far, so good, right? Questions so far?
I know we are not finished, but that's part.
Okay. The next one, we're not given a graph, we're just given an equation. How am I going to do that? Jake. Yeah, we're going to type into our calculator and get a picture, and we're going to use that picture to do the exact same thing. Oh, Mr. Kulik, I love this. Yeah, just let that calculator do the heavy lifting for us. All right. Alpha y equals, pick that first option to get that horizontal fraction bar. And now this time, remember, I mucked around with the window that we were using before, right? So I'm going to do zoom standard just to reset my window back to like a normal viewing space. And I have a pretty decent picture of what's going on. Everybody so far so good? Okay. So now I'm going to imagine my little guy here starting on the left-hand side of the graph. He starts walking. It looks like we're going uphill all the way until we get to the discontinuity, right? Everybody agree with that? So if I look, that discontinuity appears to be happening at -3. You guys buy that? Okay, so our little guy was up here. We're going to jump down now to here. This is the next part on the graph, so it's on the other side of the discontinuity. And it looks like, again, we're still walking uphill all the way until we get to here. You guys agree with that? So we started at the discontinuity, that was -3, and continue walking until we got to 0. We're using the x coordinates, right? When we're doing these intervals, always x's. So that's a second interval of increasing. So I'm going to need to write a union and then my second interval. That's the big U symbol. I have a question for you guys. That interval says going from -∞ to -3, and then from -3 to 0. Why? Could I just write it this way? I mean, we went from -∞ to -3, and then -3 to 0. Can I just say from -∞ to 0? What do you think? No, I can't say that. Mr. Kulik did it right the first time. Here's why. Think back to our definition of what increasing means. So if I pick a point, say up here, and I pick a point to the right of it that's on the interval from -∞ to 0, I could pick a point down here. Was the change in y's positive? No, man, it went down, right? So definitely can't do that. We need two separate intervals. If there's a discontinuity, that is going to stop an interval. Even if it starts back up at the same discontinuity, has to be separated. Everybody's okay with that? So you're always going to have a break in your interval at a discontinuity. Always, always, always. All right. Where were we at now? Our little man was here at the top of this hill, right? So he's going to continue his walk. We start going downhill all the way till we get to this discontinuity here on the right. Everybody agree? Looks like that discontinuity is here at +3. So again, we start at x equals 0. We end at x equals 3. Now we'll move up to here, and we'll continue walking. Oh, we're going downhill again, starting at 3, and going downhill all the way to the right. So that's going to be, I start a new interval, so I need that union. But I'm starting at 3 and going all the way to the right, so +∞. Parentheses everywhere. Everybody gets a parenthesis. It's like you're a guest on Oprah. You get a parenthesis. You get a parenthesis. Everybody gets a parenthesis. I got a couple of smiles out of that joke. It really hit a lot harder like 10 years ago when Oprah was still doing that stuff on TV. She now is too good to be on TV. Or, well, say too rich. Make more money as a producer. All right. Everybody feel okay doing this? Again, no big deal, right? No calculation to speak of. We're just kind of looking at a picture and kind of describing what we see using mathematical language, but that's all we're doing, right? There's nothing sneaky going on here. The next thing we want to talk about are extrema. And there's two types of extrema. There's maxima, that's the plural for the word maximum. And then there's minima, that's the plural for the word minimum. And actually, there's two types of maxima and two types of minima. There are local maxes and mins, and then there's absolute or global. Those two words get used interchangeably, maxes and mins. Okay, well, what's the strict mathematical definition for these words, Mr. Kulik? Well, we'll write them down, but then we'll talk about, like, really what does this mean to me? Yikes, Mr. Kulik, that's a lot of letters right there you popped on the screen. I know, guys. It's not that hard, though. Our definition reads, a maximum of a function f is a value f of c. So it's a y-coordinate, right? F of c is a y-coordinate that is greater than or equal to all other range values of f on some interval containing c. We would call this a local maximum if there are other range values that are greater or equal to f of c outside of our interval. And we would call this an absolute or global maximum if there are no other range values greater than f of c. So what are we saying here? We're saying that something's a maximum if it's the highest point on our graph. And we call that an absolute maximum if it's highest or tied for highest of all the points in the graph. We call it a local maximum if it's the highest in its little neighborhood, right? Like you might be the smartest kid on your block, but you might not be the smartest kid in the city. You might be the highest point in this little area, but you might not be the highest point on the entire graph. Same idea for minimum, except it's lowest, right? So let's just kind of, let me draw a little picture and we'll identify the extrema and like what kind they are to get the idea, and then we'll do one more example where we use the calculator also, and that ought to get us kind of through the day here. So let's say we have this graph here. How many extrema, that is, how many maxima and minima do we see in total? I see 5 as well. Okay. So I see 1, 2, 3, 4, 5 of them. Everybody agree? Okay. Of those 5, which of these are absolute maxima? Jake? Okay. Is what? Number 3, okay. Are there any other? Yeah. So it looks like 1 and 3 are the same height, right? They're both the highest on the graph. Those are both absolute maxima. You can have 2 or 3 or 4 or 5 or as many as you want as long as they're tied for first, which those are. When we do trigonometry, we'll see a function that has infinitely many absolute maxima and minima. Oh dear! It's not that complicated. It's okay. Do we see any local maxima? Five, yeah. So like if we look in just this little neighborhood, 5's the top dog in that neighborhood, but clearly like 1 and 3 are higher than it. So it's not an absolute, it's just a local. Technically speaking, you could also list like 1 and 3 as local if you wanted to. It's not necessary that you do if we're listing, you know, like absolute and locals. If something's an absolute, you don't also have to list it as a local for me. But technically speaking, it still counts. Okay. How about absolute minima? What are those? What'd you say, Lexi? 4. So there's no points that are lower than 4. Aren't all those points lower than 4? So is there an absolute minimum? No, there doesn't have to be. And this one doesn't have any because the arrows are pointing down. There's always, no matter what point you pick, there's always another one lower than it. Because we have the arrows at the end of the graph, the end behaviors, both point down. Everybody's okay with that? So that should tell me my local minima must be then 2 and 4. Since they are definitely minima in their little respective neighborhoods, they're the low dog, but definitely stuff lower than them still remaining. Does everybody feel good about what we did here? Clear on the vocab and what they mean? Again, pretty straightforward idea, right? The names are pretty descriptive of what we're talking about. I think visual makes it easy, right? If you're a visual person, I'm a visual guy. Looking at the picture going, okay, that's pretty obvious, no problem, got it. Though if you have a question or you're not sure, if it's not clear, please ask, and we'd be happy to talk a little bit more about it. Let's do one more example here. This example says, for the graph f of x equals yada, 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 use your graphing calculator to find any local or absolute extrema and determine any intervals of increasing and decreasing. Okay. Well, the first thing in the direction says is to use your graphing calculator. So I'm going to start by just plugging this thing into my graphing calculator and looking at the picture, since it's basically hitting me over the head with it, telling me to do so. To get an exponent of 4 or 3 or whatever, I'm going to use this caret button above the division symbol. Doing that moves my cursor up into the exponent so I can type like any number up there I want. When I'm done typing the 4, though, I have to make sure I press the right arrow and move my cursor out of the exponent, back onto the main line. Now I'll do that same thing to get the cubed. And then just kind of continue typing in the rest of this thing. So far, so good? No big deal. I'm going to go ahead and hit graph now. Okay, so looking at my picture, what kind of extrema do I see? How many total? 3, great. So this one is a global minimum or absolute minimum, excellent. This one right here is a, well, it's a local, right? Because there's parts that are higher, like look at the ends pointing up. And then this one over here is local min, right? So I'm going to write down the points that those 3 things are at. Now my calculator can actually tell me these points exactly, or with a high number of decimal places anyway. So I'm going to ask my calculator to do that for me so I don't have to try to estimate it from the picture. So what I'm going to do is I'm going to press second and then the trace button. That's going to access the blue command above trace that says calc. That opens up the calculate menu. This is a list of commands that you can do to your graph. If we're looking for the location of mins and maxes, What commands from here do you suppose we're going to be interested in? The minimum and maximum, yeah. So let's go find that global minimum first. So I'm going to go ahead and scroll down and pick the minimum command and press enter. Notice on the bottom of my screen of my calculator, it's going to ask me a series of questions. The first question it asks is left bound with a question mark. What the calculator is asking me to do is to pick a point to the left of the minimum that I'm looking for. So what I'm going to do is I'm going to take my cursor, which is located right here, and move it over onto the left side over here of that minimum. I'm going to do that just by using the left or right arrows on my calculator. So there goes my cursor. I can see it moving. That looks like a good spot as any. Anywhere over here is going to be fine. So I'm just going to press enter. Now it's going to ask for a right bound. So now I'm going to move my cursor over here in between the minimum and the maximum, right over here. Again, using the left or right arrows. So there it is. That looks like a good a spot as any. I'm going to go ahead and press enter. And then it asks for a guess. I'll tell you a secret. The guess doesn't really matter where you pick it. Just do it the spot you're at. It's going to take like microseconds less time if you put it closer to where the minimum is. But it takes you way more time to just like press the over button than it's going to take the calculator to use a worse guess. So just guess where you're at. It doesn't really matter. So there I go. I get the point negative 2.24682, comma, negative 9.653029. Whoa, that's a lot of decimal places. Let's round to 3, just so we don't have to write all those numbers. But that's still enough decimal places that Mr. Coolett can tell you use the minimum or maximum command and not just like the trace thing on your graph and try to guess it. Okay. Let's do the maximum now. So again, second trace. I'm going to pick command 4, the maximum command. It's going to ask me the same series of 3 questions, left bound, right bound, and guess. So the left bound, I should pick somewhere between the minimum and the maximum, right over here. So I'm going to move my cursor. That looks like a good spot right there. I'll press enter. Then the right bound should be between the maximum and this minimum over here. So I'll move my cursor. That looks good. Press enter. Guess where I'm at is fine. There's my next one. And again, I am going to round to 3 decimal places because woof, I don't want to type out all or write down all 6 or 7 of those that it's given me. You know what I mean, guys? And then my last one, if you're following along, go ahead and try this on your own. I'm going to just punch it through real quick since it's the same thing that we've done a couple of times, picking the minimum command, left bound, right bound, guess, and there we go. Again, I'll write this down rounded to 3 decimal places. 1 decimal place, Mr. Coolett. What are you, crazy? I don't know, I just misspoke. Everybody feel okay about using your calculator to do this? Did you do this last year? I suspect some of us did, right? At least some of us. If you didn't remember how to do this and you get to the homework and it's like, yo, still don't remember, fire up the video, skip, forward to the end to where I do it on the calculator again. You can rewatch it. Be helpful if you get stuck on the calculator parts. But that's not the entire question, right? What else did it ask for in here? It asked for the intervals of increasing or decreasing. Okay. Well, let's go back and look at our graph here. So we start on the left side with our little guy. He starts walking and he's going downhill all the way until he gets to the global minimum. So he started at the far left end, negative infinity, and he goes all the way down to the global minimum at negative 2.243. And remember, intervals of increasing and decreasing. Always get parentheses. Don't get confused because we have points here and intervals down here. Points are x, y's. Intervals are lower bound, comma, upper bound. They're both x values. They look identical right now. Don't get confused on that. It's easy to get tripped up. Increasing and decreasing, domain and range always are intervals. Pairs of x's. Points are the locations of maxes and mins, like extremas, are always x, y's. Okay? Just to be clear, because they look identical when I write them down like this, right? You have to know from context that one is a point and one is an interval. Oh, context. All right. So now we're down here. We continue walking. So we're starting at the lower bound, or the global minimum. And we walk to the right, uphill, all the way to the local maximum. So that's going, increasing. We start at the global minimum. And we walk all the way to the local maximum. And now we're up here. We continue walking to the right. Oh, we go downhill from the local maximum to the local minimum. So we start at the local maximum and we go to the local minimum downhill. And then we're here, so we continue walking to the right. Now we're going up, starting at the local maximum, and we continue walking uphill forever. So we're starting at the local minimum, and we walk uphill forever. Notice here that, like, the x-coordinates for my extrema were the same points in which we changed from increasing to decreasing, right? So those locations, those x-coordinates should always match up. The locations of your extrema should be the same locations where we change from increasing to decreasing or decreasing to increasing. Everybody's okay there? Okay. That's as much as I want to do today. At this point, you guys should also be able to do 13 through 18. That'll be the last of the problems for your problem set on Sunday. So Sunday's problem set you should have done up through 18. Everybody okay with that? So to turn in your problem set, you're going to be turning this into OneNote, right? Let's talk about if you decide to write your stuff on paper, how do I get what I've written on paper into my OneNote? Everybody cool with that? Okay. So I'm going to use, Lexi, I'm going to use your OneNote here as an example for everybody. So in your OneNote, you have a section for class notes. Lexi's been writing her class notes in the OneNote already. I suspect she'll probably write her homework in the OneNote also. And in fact, here she's already got some stuff in here, like the syllabus. If you're choosing to do that, that's great. You can always do that. You can always handwrite stuff into your OneNote as your homework. No problem. Everybody okay with that? If you're doing that, I would suggest you take like the problem set from the content library and you just copy that and then go to your thingy-majigger and you just can kind of like drop in the problems. And if you do that, though, like do your work like off to the side so that you have some space to do some work. And it's not just like scrunched in there and Mr. Kulik has a devil of a time trying to figure out if you did everything because it's like jumbled all over the place. But you're certainly, like encouraged to do that. That's perfectly fine. Everybody okay there? Now, what do you do if you did your work on a separate sheet of paper? Okay, I thought that could just Control-Z that out of there. I'm going to delete this out of here for you, Lexi, so it's not in your... Any changes I make, I'm going to undo, just so you know. All right. So, what do you do if you have your homework on a sheet of paper? So, if you want to practice doing this now, I would encourage you to do that. if you think you're going to be this type of student. Take out any old sheet of paper, doesn't matter, scrap, it could have something on it, could not. All we're going to do is just a little test. Take out your cell phone. If you have an iPhone, did you know you can like make a PDF of a scan a paper with your iPhone? Some of us know how to do this, some of us may not. I'll tell you the way that I know how to do it. Some of us have apps already to do this specifically, but your iPhone can do this through Notes. So if you pick your Notes app, you need to have an iCloud folder. So if you open up like your notes and you go to the folders and you have one for iCloud, you pick that folder, you make a new document, and you should have a little thing with a camera on it. If you press that camera button and you pick Scan Document, you can then, like scan with your camera a sheet of paper, and it'll take a perfect PDF of that into your computer or into your cell phone. So like you have a scan, you can go ahead and hit save or whatever, and then you can just use that little like sheet of paper with the arrow on it to attach it to an email it to yourself. Okay? If you don't have an iPhone or you don't know how to do that or you don't have an iCloud folder or whatever, just take a regular picture with your camera. The quality won't be quite as good, so you have to be a little bit careful. But you can do it that way as well. Email that picture to yourself. Use your Notre Dame Prep account. Okay? Once you've done that, you're going to open up your email that you'll have to yourself. You'll save the image that you just emailed to yourself to your desktop, and then you can just drag that image into OneNote. So I'll make like a page, and I'll just like drag my image in. And here's some bears eating apples in the forest that I thought was a funny picture that I saw on Facebook that I screenshotted. And you just drag the icon in. That's why I save them to the desktop, so that it's easy for me to find this. Don't save it to your download, save it to your desktop. If it's a PDF you're saving in, when you drag it in, it'll give you this option. Pick Insert Printout, and it'll just plop the PDF right in there. Give it a shot. Try right now. If you get stuck, I'm going to be walking around. But if you're somebody that's like, yeah, I'm going to do this on paper and then import this into OneNote, try this right now so that if you have a problem with it, you can get a little bit of advice or figure this out right now. We have, 20 minutes still left of class. Give it a shot. I'm going to walk up and down here in just a second. If you get stuck on something, you can talk to me about it. Maya. Of course. Lexi, I'm going to get rid of these fun bears. Oh, I want to show you one more thing. I'm sorry, one more thing. So let's say I did this. I drop in the bears, and then I close my OneNote real quick. Come on, OneNote. I'm asking to close you real quick. There it goes. Lexi, do you still see the bears when you look at your end?
Yeah.
Dang it. You're not supposed to.
Oh, but they went away.
Yeah, they went away. Even though I put them back, they're still gone, right? Here's what happens. How does OneNote work? OneNote takes your stuff. It sends it up to the cloud. From the cloud, I have to pull that information back to my computer, or vice versa. My computer has to send it up. You have to pull it down. What I did when I put the bears in and then immediately exited out, I didn't give my computer enough time to send my information to the cloud, which means Lexi can't get it. The same thing is going to happen if you drop your images of your homework in to your OneNote and don't give your computer time to sync before you close your OneNote or turn off your computer or something. What we can do to prevent that from happening is before you close out your OneNote, up here where it has the name of your folder, right-click on it, pick Notebook Sync Status, and hit Sync All, and that'll push changes up to the cloud When your changes are all done, when your bar gets all the way green, when everything is finished, you can close out your OneNote and rest assured all of the things that you've done are now to the cloud. Mr. Kulik will be able to get those changes on his end when he goes to look at your homework later on. The likely situation, if you get an assignment marked as missing or incomplete and you're like, yo, that thing was in there and it was done, was probably you just didn't give it a chance to sync. Try resyncing. Send me another email. Let me know that, hey, I don't think everything was synced. I just resynced it. Can you check again? As long as you do that within the first week, there's no late penalty for me because I get that happens. Try not to let it happen, though. It's much easier for me to have everything graded on the one day that I grade, and I have to go back and look for 10 people's things that just didn't sync. Everybody okay? All right. I'm going to close this. I'm going to get rid of these bears, Lexi. That's what those were. If you wanted your bears, I'm sorry. They're gone. Okay. I'm going to go walk around and see if anybody has questions, troubleshootings. I'll stop by. Oh, of course. I'm going to go down this side of that so we don't play chicken as I walk by. Whatever drops. Okay. It's the same. Put right here. Now you have a bunch of stuff right here. Is this stuff all stuff you're using this year? Right, so let's do this. Right now.
Wait, no.
Biology after right this. It doesn't go away, it just gets out of here, so that you're sinking it doesn't take so long.
Okay.
So anything that you're not using anymore, I recommend. And that'll improve your performance on this machine right now.
Okay, yeah, thank you.
Yeah, absolutely. Okay, sure, what's up?
I'm a junior right now.
Yeah, Josh, right?
Josh Jacob.
Yeah, no. Josh.
Hi, I'm gonna come over to this side.
Big Jason.
Josh Jacob.
Older Jason.
Yeah, I know exactly what's the problem. See up here?
Driving your mom to
What?
You driving your mom to even?
I'll highlight those. No. Well, it's your windows on.
Oh, okay.
So you just.
Oh.
Yeah, so what's happening here is it's trying to plot these things. You look at stuff, step up one, it's trying to plot stuff outline out to it. If you look in at your L1, your list 1, list 2, your X's, which have no Y's. So it's trying to plot an ordered pair with X coordinate, but no Y coordinate, and that's why it's giving you the error.
Okay.
If you just have these plot 1s and 2s or 3s off all the time for graphic functions,
Yeah. Thank you. Okay. It's like, okay, cool.
yes. Okay? Yeah, you can just tear off the last page. And if you guys remember the syllabus sign-in sheets, if you don't want to give me a paper copy, that's fine. You can always put it in OneNote. Like take a picture of it, put it in your OneNote. You don't have to give me a physical copy. If you're like, yo, as soon as somebody signs this thing and hands it to me, I'm going to lose it like 15 minutes later. Just picture, scan, whoop, done. I did not give you a physical copy of the syllabus. I just gave you the digital. So you can print your own, or you can just put it in OneNote, sign it in OneNote, and just be done with it. It's there, right? Like I don't care how you give it to me. Just like at some point somebody should sign the thing, whether it's a digital signature with the stylus in OneNote, It's an actual physical copy. It's a physical copy that you scan and upload. Whatever. I'm okay. Try to be flexible. Thank you, Sarah. You know, like
if I get it in Friday, like what?
oh, plenty of time. Yeah, that's perfectly fine. Anytime this week, I think is fine. Even like, you know, even like Sunday, you know, like whatever.
Is it a grade?
It is a grade. Yes, you may. It's a 5-point homework assignment. It's not like it's all the points in the world, but it's like 3 points, you know.
What are we doing Friday?
What are we doing on Friday? Well, let me remind you guys about something. Remember when we talked on the syllabus about every so often we're going to get a homework quiz, right? Every chapter or so we're going to have a homework quiz. Now, have we had one yet?
Yes.
Well, okay, we didn't have but not for this chapter. We did a homework quiz, but it wasn't for the chapter, right? It was just for like a first day of class thing. And we've done what, about half the chapter here? We're at, I don't know, through 4 sections. Feels like there's probably a homework quiz in the near future. Friday might be a good day to do that. So if you're like, remember the homework quiz, they're closed book, they're unannounced. Sometimes we'll do stuff like this where I give you an idea like, hey, it's probably coming. And they're just based on the homeworks. So if you're able to do like 1 through 18, you should have no worries at all, right? And the way it's graded, it's not necessarily right or wrong. It's like overall impression. So like I'm going to look at the stuff you didn't go, okay, is this A work, B work, C work, and we'll assign numbers like 10, 9, 8, 7, whatever, based on what you did. So as long as you're able to do stuff, even if it's not necessarily all correct, you can still get like 7s and 8s and stuff pretty easily. So it's usually never like an unmitigated disaster. And remember, these are only 10% of your overall. So it's not like it's all the points in the world. The homework is worth 2.5 times the homework quizzes. You know, so that's homework is 25%. Does that feel okay? So we'll probably do that. We'll probably talk about maybe start the next section depending on time, number of questions we have about homeworks, you know. Try to be a chill day where I don't sit here and try to lecture for an hour and 20 minutes straight through on a Friday. Yuck! I don't like doing it either. That feel good to you guys? All right.